In this video, I'm going to be going over my notes on integration by parts. So when we were finding derivatives, we learned how to find the derivative of a function that was actually the product of two functions, and we used the product rule for that. Well, integration by parts is integration's answer to integrating a product. So in this particular lesson, the functions that we have to integrate will be products. And so this little formula you see here may look a little bit confusing, but we're going to break it down so that by doing some examples so that you can see exactly what we mean by the u and the dv, the du and the v. All right. So when using this formula, this is what we're going to be starting with. The left-hand side over here is we're going to be integrating some function u times another function which we're calling dv. So it is the product of two functions, u and dv. Now, as it says here, when choosing u and dv, make your selection so that the integral becomes simpler, not more complex. And you'll see what I mean as we go through some of these examples. So the best way to do this is to just jump right in, and let's do the first example. Evaluate the integral x times e to the x dx using integration by parts. So the first thing that you want to notice here is that we have a product. Two functions, x and e to the x, are being multiplied together. So what we want to do is we want to make one of them be the u and one of them be the dv. All right? And so I chose to let u be equal to x, and I chose to let dv be equal to e to the x dx. Notice that the dx part comes along with the e to the x. The easiest way to remember that is because the dx goes with the dv. So what we have here is basically the integral of x times e to the x dx is now in the form of the integral of a u times, this is not writing very well, dv. All right, again, u is equal to the x, u is equal to the x, and e to the x dx is my dv. So it's kind of like substitution. Once we've determined what u and dv are, we need to find the derivative of u. And so that's what we're doing down here. You always find the derivative of u. So given u is equal to x du, which means the derivative of u would be the derivative of x is just 1 dx. All right, so we're going to have that dx at the end of it. Now, the dv, we have to integrate. We want to find if dv, you can think of that as being the derivative of v. And so if the derivative of v, dv, is equal to ex to the x, we want to find v, so we have to find the antiderivative. All right? So what we're doing here is we're finding the antiderivative. All right? And so we already know how to do that. So given dv is equal to e to the x dx, v is equal to the antiderivative of e to the x dx, which is just e to the x. So what we have now is we were given u, we were given dv, we've now found du, and we have found v. We now have all of the parts that we need in our formula up here. And so now the process is to put them all together in the little formula. So we substitute these in. The formula says that the antiderivative of u dv is equal to uv minus the integral of v du. All right, so we know that u is equal to the x. We've now found that v is e to the x minus the antiderivative of v, which again is e to the x, and du is just dx. So there it is. We have uv minus the integral v du. All right, now the last thing to do is to integrate that. And so we know how to find the antiderivative of e to the x. The antiderivative of e to the x is e to the x. So the final answer becomes x times e to the x minus e to the x, and don't forget to add the plus c. These get easier as you do more of them and you basically learn the procedure. So let's do another one. Oops. All right. Evaluate the integral 3x e to the negative x dx using integration by parts. So again, notice that we have a product of two functions. The first function is 3 to the x. The second function is e to the negative x dx. And so we want to choose a u and we want to choose dv, okay? Because that's what the formula u dv is what we're starting with. Now, just a little hint, anytime you have an exponential function and an algebraic function, 3x is an algebraic function, e to the negative x is an exponential function. You always, always, always want the exponential function to be your dv, all right? That means the algebraic function will be your u, okay? So, just like in the last problem, now that we know what u is, we have to find the derivative of it. And so the derivative of 3x is 3 dx. We always tack on that dx at the end. Then the dv, that's the derivative of v, is equal to negative x dx. We want to find v, which means we have to find the antiderivative. And that's what I'm doing here. So the antiderivative of e to the negative x is negative e to the negative x. And again, we should know how to do that from previous lessons. So now that we have all of the components of our formula, all we have to do is put them all together. So we want the formula uv minus the integral of v du. That's what this is equal to. The integral of u dv equals uv minus the integral of v du. So u is negative 3x, or is 3x, and then the v was negative e to the negative x, and so we just put the negative out in front. Then you might wonder, why did this minus become a plus? Well, the v is negative e to the negative x, and the du is 3 dx. So when you put those together, you're going to have 3e to the negative x dx, and you can put that negative sign out in front, and a negative times a negative becomes a positive. Once you have that, the last thing to do is to find the antiderivative of 3e to the negative x. And once again, that's going to become a negative 3e to the negative x. And so our final answer is negative 3x e to the x minus 3e to the negative x plus c. Let's do one more in this video. Let's change color. Purple sounds good. In this particular problem, because it's a quotient, and integration by parts works when we're multiplying two functions together, let's change the quotient into a product. And so we've done this when we're doing derivatives. You can take the denominator, e to the 3x power, and bring it up to the numerator and just change the sign of the exponent so it becomes e to the negative 3x. And so now we need to choose u and dv. So in the last problem, I said always, always, always let the exponential part be your dv. And that's, again, what I did here. That means the algebraic part, 2x plus 1, is u. Once again, we have to take the derivative of u. So the derivative of 2x plus 1 is 2 dx. And we have to find the antiderivative of dv. And so we end up with negative 1/3 e to the negative 3x. We then put those together into our formula, uv minus the integral of v to u. So u was 2x plus 1. The v is negative 1/3 e to the negative 3x. And again, I like to put the negative 1/3 out in front, then the algebraic part, then the exponential part. Finally, we have then minus the antiderivative of v du. So we have v, again, is negative 1/3 e to the negative 3x, but du is 2, so combining those, you get this part right here. And of course, the minus and a minus become a plus. The last thing to do is find the antiderivative of 2/3 e to the negative 3x, which is then negative 2/9 e to the negative 3x. And putting it all together, we get our final answer. Okay, in addition to this, make sure that you watch some of those other videos that I posted. And as always, if you have any questions, send me a message and more, and I will do my best to get back to you as soon as I possibly can.